Right. So let's start again. So we were talking about our topic. So topic for today is software testing, right? So we look at the definition of software testing. So basically, software testing is a process of executing the program with the intent of finding faults. What does that mean? There are software developers, then there are business analysts, then there are marketing staff. Okay, so in a company, different people have different roles. So if you look at the CEO of the company and the marketing team, if you take the CEO out, he's basically looking after the whole organization. The marketing department's job is to go and sell software ideas or to, sell the, we will say, skill set of the company. So they will go and say, look, we have Java programmers, we have PHP programmers, we have Python programmers, and then they'll try to bring a business. So when the business comes into the company, we have the BA team, business analyst team, who will sit with the client to understand what the client wants. Okay, to understand the requirements. After that, it comes to the software development team. Actually, in this moment, there are three teams sitting together. One is the software development team, other one is the BA team, and the third one is the quality assurance team. So, job of the quality assurance team, there are actually two very, very important topics that we will cover today: verification and validation, right? So they need to get involved from day one. Some people think the software quality guys are coming after we develop the software. No, that is very wrong. SQA or software quality assurance has to start from day one, the day you bring the business to the organization. All right. So the job of the SQA or the quality assurance team is to find faults. That's their job, right? So some people don't like them. Developers say, "Ayyo, megalange vede, වැරදි හොයන එක." Right? So their job is to find faults of what we do. Well, that's their job. Somebody has to find it. We'll also see why it is far cheaper and better for the internal QA people to find faults. Because if it goes to the client, you're not going to have your job next time. You're going to lose your job. So it is better your friend is finding the fault than your customer finding the fault, right? So your friend in the QA is actually doing a job for you, a big favor for you, right? I'm saying because some people think we can't work with QA. Well, they're saving your job. Now, when you're talking of QA, there are certain other terminology come into play. Like say, for example, is it debugging? Is testing debugging? Or is debugging is testing? Well, there's a huge difference actually. Debugging is removing errors that was there, right? That is debugging. You find a problem, you're removing it. That is called debugging. Whereas testing is to test the errors that you don't know that there are. Okay. So when a programmer writes a code, he's debugging because he knows there are some issues and he's removing. But only when the testing is done, he will or she will find out undiscovered bugs or undiscovered errors. Okay. So that means it requires an excellent eye for detail, isn't it? Everyone can't do that. Yeah. So, and also another thing, we test our program for both valid and invalid inputs, isn't it? So, let's say, for example, if there is a text box that says, please type your age, we generally type something between 1 and maybe 100, right? So that's the normal age that we believe. But what if you type 0? What if you type -5? What if you type 5,000? Will the program crash? Will the program work? That is the job of the tester, right? So we type something and then we try to compare how it works, right? We compare to see whether the output is same as expected. So that's the job of the testing staff or the testing department. Now, why is that important? About 70% of the development time is spent on testing. What does that mean? If you have 100 hours for developing your software, of that 100 hours, you are spending 70% of the time on testing, not developing, not coding, testing, right? So because of that, if you look at the cost of software development, testing is very expensive because it's taking 70% of the time, isn't it? So if you can somehow reduce it, you are saving time for the cost of the software and also time for the development of the software, right? Which means more profits. Less time you spend, higher profit you get, right? And if you look at the levels of testing, there are different levels also when it comes to testing, right? All kinds of levels. So now we already saw debug as one level. Yeah. So that is like the top level or the easiest, I would say, level. Yeah. It is defined as the successful correction of a failure. So when you say our developer is debugging, he's saying that he's successfully correcting something. He found the problem, he fixed the problem. That's called debugging, right? Now, demonstrate the process of showing that major feature work with typical input. That is, when you ask for the age, you type 25, it works. That is called demonstration, right? And testing is going beyond that, typing 5,000, typing -10, whatever. So demonstration is the normal behavior of the software. So when you give to the customer, you assume they use it using the normal behavior, right? Then we have two big words, verify and validate. What does that mean? These are also levels, by the way, right? Verification is the process of finding as many faults in the application under test. We also call it AUT, application under test. So in simple terms, it's called, are we doing it right? That is verify. Meaning there are a bunch of software developers, they're writing code. So you want to know whether they are doing their job right, isn't it? Are they properly coding? Are there any problems? So we can find issues and whatever. That is verification. There is also validation. What is that? Now, they may be doing it very well, but what if they're doing the wrong thing? They are building the wrong product and they're doing it very well. That's also wrong, no? That is called validation. Are we doing the right thing? For example, let's say you want to repair your car, right? You want to take it to a garage. Maybe there are two garages. One garage says, okay, you bring it in the evening, I'll give the car in the morning, right? Other person say, well, we need 3 days. Where will you take the car? To the place that says that they will give you the car tomorrow morning. And then you give the car to them and tomorrow morning you go, you see they have removed the engine from the front and they fix it to the back. And the car is not moving now. So is it correct? Well, they did it very fast, but they did the wrong thing, right? So the validation found out that it's wrong. They were doing the wrong thing, isn't it? So software also same. Verification is to see, are we doing it correctly, right? Validation is doing testing to see whether we are doing the correct thing. Are we building the correct thing? Now, how do you know whether we are doing the correct thing? Validation compares the customer requirement, right? That's where we will find out. The customer wanted accounting package. We are building an inventory package. That is wrong. So that is validation. Yeah. Prevention or prevent is to avoid errors in development of requirements, design, and implementation by self-checking techniques, including test before design. So you don't see the word testing here, right? Because we are talking testing levels. So the last one, prevention, is you have a process of removing issues or at least reducing issues before it happens. Right? These are called preventive measures. For example, you don't sit at the computer first thing. You sit at the table with pencil and paper to design the UI, for example. You don't design the UI using code. You design the UI using paper and pencil. Then you use a tool like Figma, and then you show that to the customer. Don't write any code. All right. So Yesterday I was doing finally a project evaluation, and then I asked, where is your UI screens? He said, sir, I'm very good at my coding. So I did all my code UI using my code, and he showed me. Then I said, okay, there's an issue here. There's a problem in this screen. What do you do now? All right, so I can fix that. I said, well, that takes time, because when you try to fix that, you might introduce another problem. If you've done a very basic UI using, Figma is very simple, right? You can draw boxes, you can drag, drop, and all that. You could have easily fixed it on the UI itself without writing any code. Now you are going to touch the code, and you might introduce new issues to another part of the code. So prevention is that. Prevention is you're trying to reduce instances where you might introduce new problems, right? So it might be at the stage of business analysis, it might be at the stage of designing, anything for that matter. Now, if you look at the definitions from the World Organization, for example, IEEE says, testing is a process of exercising or evaluating a system or system component by manual or automated means to verify that is satisfied specified requirement. So what do they say, IEEE? Process of exercising or evaluating a system or the system component. So either the whole system or a part of that, either manually or automated means, right? So it's about either you are testing the whole system or a part of the system, either manually or by automated systems, and make sure it is satisfying the customer. Customer wanted something, you are building something, are they matching? That's the definition from IEEE. And Myers says software testing is a process of executing a program or system with the intent of finding errors. That was a definition we had earlier, right? The intention is to find errors. That's software testing. And Hetzel says it involves any activity aimed at evaluating an attribute or capability of a program or system that determining that it meets its required result. So what do you mean by evaluation? Evaluation is like you're comparing, right? Is it same as this? Yeah, so that is evaluation. Let's say you are learning this unit here, and at the end of the semester, you are evaluated. What does that mean? So you should be able to prove that you know software testing. So we have a test then. That test can be to see whether you remember few things, but more than remember, to see whether you can do something. Like, can you develop a test plan, for example? It's not successful, right? Same can be said for software. Now we heard two big words, right? Validation, verification. Now, in a shell, software is all about these two. That's why I say these two words are very, very important. Shell and validation. Okay. Why is it all about that? Well, we'll see that. Right? Testing errors. No, that is not testing. It is also not the process of showing that a program performs of intended functions correctly. That is also not testing. Testing is not showing that, look, my program is working without any trouble. No. Process is a process of establishing confidence that a program does what it is supposed to do. Also not that, right? So none of this is not testing. That is not our job. If it's the customer or to demonstrate the program saying everything is fine. No, that is none of the intention of the people who are doing testing. Remember that. Okay. The job of the tester is to find faults. Very simple. Okay. Many people forget the main idea. Now, talking of testing, there are also two sides of it. There is negative testing and positive testing. Now, what is the difference of that? Right? Negative testing and positive testing. So, negative testing, or rather, let's start with the positive testing. Positive testing operate the application as it should be operated, right? Meaning you are using the application, and then the way it should be used, you are using it, right? So when you do that, you check, does it behave normally? Is it normal behavior? What about some legal test data? So you provide, for example, when the box says, what is your age? You give, 10, 20, 30, 50, whatever number. And there is also something called boundary values. Like if it is the age, normally the boundary value is 1 and 100. Okay. So we can test it and see beyond that, including data values at the boundaries to test if it fails. So what if I put 101 and 0 and -5? Does it work? Right? That is called positive testing. And then before we write the software, I told you we are supposed to develop a test plan, isn't it? So we need to test the software, take the output and compare that with the test plan and see, okay, is it the normal behavior? Right? Is it the normal behavior? Then basically to see whether the application is functioning correctly. Right? That's called positive testing. Negative testing is about testing for abnormal operations. So by the way, positive testing is for operate the application as it should be operated. Negative testing is test for abnormal operations. Like we try to crash the system. Yeah. That's also testing, isn't it? Testing with illegal or abnormal data. Now, let's say there is a box called what is your age? I'm typing ABCD. What happens now? Will the system crash? Right? Oh, I type 1 million. Oh, I type 100 million, 1 billion. Can it work? Right? So that's negative testing. And then intentionally attempt to make the things go wrong and to discover or detect where it is crashing. Right? So we are testing to see, does the program do what it should not do? That's important, right? You see, that is different to the one we saw earlier. What does the program do in the first one? Next, we are testing, does it do what it is not supposed to do? Okay. Or the other one, does it fail to do what it should do? That's also important, isn't it? Does the program do what it should not do? And also, does it fail to do what it should do? Both are equally important. Now, people might think, okay, negative is that good? Yeah, there is. Actually, there is positive in negative testing, right? So the positive side of the negative testing is the job of testing is to discover errors before the user does. User meaning customer. You see, customer finding out the problem is very expensive. If you are a developer, you may have to go home if you have done some, very silly mistakes. A good tester is one who is successful in making the system fail. Remember that. A good tester will make the system fail. Then only we say good tester. We don't say good programmer. Good programmer is the one who makes the system run without any errors. So the third or the last point is very important. Mentality of the tester has to be destructive, right? Destructive meaning I am going to crash this. I am going to hack this. That is the mentality of the tester. Opposite of that of the creator or the author, which should be constructive. The programmer is there to make something great happen, and the tester is there to make it crash and show the programmer, look, there is a problem here. Now, we spoke about two of these words, right? The validation and verification. In fact, this is also known as V&V. Okay, V&V is the word we use. So the whole life cycle, when it comes to software life cycle, there is something called SDLC, right? Software development life cycle. So entire life cycle must go through V&V, verification and validation. So when you sit down with the business analyst, you need to review the requirement very well as a QA person. And also, if you are into code inspection, well, then you need to do that also. You need to have a process of code inspection. And then at the end of the exercise, after the product is released, you also need to be testing the product. Now, by the way, the QA department also has different people in the department. We will look at the job roles, right? There is a QA, head of QA, then there are QA engineers, then there are testers, there are writers, all kinds of people are there. So it's a big department, by the way, as big as the software development department. And third one is there should be V&B activities at each stage of the SDLC. Meaning from the information capturing to delivery, there has to be V&V. V&V is verification and validation. Are we doing it correctly or are we doing the correct thing? Two different things, right? So the whole point of doing this is to make sure that the result of our process, our activities are as required and specified by the customer. That's the whole point, isn't it? Then comes the definitions of these two, verification and validation. What does that actually mean? Right? Verification involves, remember this, okay? This will be tested in your exam to see whether you understand the difference between verification and validation. Verification involves, okay, there are two involves. Checking that the, what is that, repeat text? That the software conforms to its specification. Okay? Meaning there is a specification written. We are verifying to see whether the software is properly done. Okay. You should check that the system meets its specified functional and non-functional requirements. So the job of the QA person or the team is to check the system whether it is meeting the functional and non-functional requirement. And validation, now what does that mean? Okay, let me get back to the slide. Okay, I fixed the typo. Right. Whereas validation is more general process. What does that mean? You should ensure that the software should, oh God. Again, there is a typo here. You should ensure that the software meet the expectation of the customer. Right? So, big difference, right? I think the next slide is simple to understand. This is the summary of that validation and verification. So, validation, are we building the right product? Verification, are we building the product right? There is a big difference here. අපි කරන්නේ හරි වැඩේද අපි හරියට වැඩේ කරනවාද? ඔක තමයි දෙකේ වෙනස. Right? So, big differences. And here's another way to put it. Goal of the verification and validation process is to establish confidence in the customer. So we are going to give confidence to the customer that the software system is fit for the customer, right? Customer can use the software, but also it doesn't mean the software system is free from errors. Remember that. It does not mean the software is free from errors. So there is no software in the world with zero errors. There is nothing. There may be one error. We don't know. We are yet to find out. That is the job of the QA staff. Now, if you look at military or medical kind of software, there may be very, very small margin, right? Still, there may be one or two. But if you look at the commercial software, there may be so many. So that we don't know. But remember, the verification and validation is to make sure software is to be released to the customer so that it is fit for the customer. Does not mean it is free from errors. Because you can't do that. Almost impossible. Right? Now, talking about the validation and verification, there are two ways of testing it as well. There is something called static testing. Then there is also dynamic testing. So static testing is suitable for validation. Okay. Meaning in fact, static testing does not require any code. Static meaning you're checking the customer requirement and most of the time the system analysis document to see whether the BA staff has understood the customer requirement. So it's done during requirement analysis and designing. Okay. Then the SRS is tested to check whether it is as per user requirement. Generally, when it comes to a software development cycle, you develop something called the software requirement specification. It's a document, a big document. You write it with the generally BA team writes it, starts writing it, and then maybe the developers connect to it so that they work together, right? To make sure the BA people write the basic requirement. The technical people might write stuff like, database design, user flow, some user interfaces and stuff like that, which all goes to the SRS. And then you verify that with the customer. So that's basically, you validate actually, not verify, you validate with the customer. So you use the following techniques in order to do the static testing. Code reviews if the code is available. Code inspection if the code is available again. Walkthroughs. That means you can take the customer or the BA staff step by step, showing them different things. Right? There is also something called software technical review. So there may be a senior technical officer, CTO, sitting down with the, let's say, architect. And then you go through to see whether the architecture is fit for the purpose. Let's say, for example, if you are getting million requests a day, you need to design it in some way. But if you're getting like 50 requests a day, you don't need a heavy duty, system like as such. So that is the technical review you're making. Now, the next one, the dynamic testing, is for verification. Now, this is where you have the code and the application ready. It's running already. It might be the whole application or a module, right? And what are the techniques? Well, there are things called black box testing, gray box testing, and also white box testing. We'll see them in detail later. So these are the two kinds of testing we do for two kinds of types. Like validation, we do certain things. Verification, we do certain things. So remember, validation doesn't require code. If it is there, yeah, we can check it. But verification, you need software. Now, we talk a lot about theories, isn't it? Let me show you an example. So what I did was I got this code. This is a SQL code, right? This is not Java or anything. This is a SQL database code to check the leap year, right? After writing this code, there is also 15 test cases developed. There is a code written to get the leap year, and then to see whether it is running properly, 15 test cases are done. Now, what is a leap year, by the way? Can somebody tell me? What is a leap year? Can somebody tell me? What is leap year? Anyone? Okay, an year with 366 days. Ishan says. Okay. So when does it happen? How does it happen? It happens every 4 years, isn't it? But there are also other instances where this happens, like when the year is divisible by 4, 400, stuff like that. So there is some logic there. So if the year is divisible by 4, yeah, it's a leap year. If the year divisible by 100, not 100 actually, then it is also a leap year. And if the year divisible by 400 also, it's a leap year. So that's the general sort of understanding, right? So with that knowledge, in fact, you can write this code in any language. Here's the code, right? So this is a SQL. This is just like any other function. So we have the name called function, and this is the function. F is leap year. F stands for function. Is leap year is the case. So we are returning a Boolean value, right? 1 for leap year, 0 for no leap year. And we need to pass a parameter. So we are looking to see whether year is not null, right? If it is null, we return. If it is less than 0, also we return. Okay, -1 that is. And then we check, is the year divided? Actually, this is not dividing. This is called modulo operation. That means you divide by 4 and see the balance. I hope you know what modulo is, right? So modulo is you divide a number by this number and then find out whether there is a balance or no balance. So we are saying take the AI here, which is coming from here on the top. And if it is divisible by 4, and then check the balance. If the balance is 0, then we think it's a leap year. If the AI year is divided by 0 and the balance is not 0, then also it can be a leap year. And if the year is divisible by 400 and no balance, again it's a leap. In all other cases, return 0. Right? So that's the plan. Now, here are the test cases. There are 15 test cases, as you can see. Right? So, what is going on here? This is called a test data. Okay? So, first column is serial number. So, that is the test case. Test case 1 to 15. Then we have year to test. So, you see, we are also having borderline numbers. So, we have -1, -400, 100, and then normal years, 400 is there, number 4 is also there, and then bunch of others. And expected result for minus numbers, we should be getting -1, -1. And for these, we should get 0, 0, 0. And for these, we should be getting 1 because these are leap years. And observed result is after you run the test, what did you get? So this is the expectation. This is the final or actual result. And is it a match? Now we are expecting, let's say -1, we are getting +1. Then it's not a match. But here it is matching. So looks like all our 15 cases are passed. Right? So is it okay? Well, looking at it, it's like okay. But then we need to go beyond this as well. Now, for example, here are some cases. Identifying, actually, this is not a directly QA, this is not a black box test. This requires a white box test where you're looking at the source code. So if you remove AI mod 400 equal to 0, you are going to lose 1999 to 2000 year. So year 2000 problem. So this is called the Y2K problem. Luckily, we have it there. What if someone enters a floating number like a 2010.11? Now, this is also a valid number. So what happens? Entering year as characters, so as a string. Now, if I type 2010 as English, TWENTY, something like that. Or entering the year as null or 0. So some of these things may not be in the code. So we don't even have it in the test case. Now, if you look at the test case, we don't have that, right? We have only valid numbers. So what if someone types English letters? What if they type the year 2000? What if they type 2010.11? Don't have null or 0 as well, right? So although we have 15 test cases, we still need more test cases, right? This is why we need the job of the QA engineer. Now, sometimes if the programmer wrote these test cases, the programmer may not thought about these cases, right? So it's a job of the QA engineer to come up with these kind of additional cases as well. So, but then next one is why testing is necessary. Why do we need testing? There are lots of different cases or other reasons for testing. First one is called the technical case. We need the testing due to these technical cases. One, competent developers are not infallible. What does that mean? The programmer may be very, very experienced, but even the most experienced programmers are human. They can make mistakes. Second point is very important. What does that mean? The implications of requirements are not always foreseeable. That means when you meet the customer for the first time and talk about requirements, at that time, you might not know what the implications are. So maybe customer says, I want to store the age. Now, later he might say, no, look, I want to calculate whether they are maybe adults, right? And the software will be used every year also. This year, next year, whatever. So if you are storing the age of the person, what about the next year? Next year age is wrong. So maybe you should store the year of birth or the birthday. That way you can calculate the age anytime you want, right? So this is where we need to do testing. Number 3, the behavior of a system is not necessarily predictable from its components. So there are two things here. A big system is made out of many small components. So sometimes the components are running properly. When you test the component, they are working fine. But when you put it together to the system, then there might be issues. So how do you handle that? How do you do it? Right? So in that case, you need component testing separately and integrated testing separate. Integrated testing is where you put all the components together and then you do the testing. Next is languages, databases, user interfaces, and operating systems have already bugs. Now, even the Windows 11 has bugs. So due to Windows 11 bug, if our system is not working, we have serious problems, right? Yesterday, I was trying to get WordPress, one of the WordPress versions up and running. Then I realized the PHP version has a serious issue with the WordPress. So if I don't have the right PHP version, WordPress is not running. It is throwing all kinds of errors, right? With the error message, I can't find out what the error was, what to do. So after doing some research, I realized it was a very simple case of upgrading PHP. And when I did that, all the errors are gone. Yeah, so it's a case of a version of compatibility issue, but these are some of the things that are beyond our software that we have to undertake as well. And the last point is also very, very important. It says reusable classes and objects must be trustworthy. That means in any organization or any individuals, as you live the life of a software developer, you start collecting tested components, like say, for example, user management component. So you are a Java program and you've written a good user management component like user registration, password forgot, multiple password, or rather old password cannot reuse feature, password strength feature. You write all those and you keep it as a module, right? So if you develop multiple projects, you may have used that component in multiple projects also. So what does that mean? You have a very good tested component of yourself. So next time when you're building a new project, you can immediately add this without rewriting the whole thing, isn't it? So that's why components are very interesting. So we call it a reusable component. That makes you a faster programmer as well. And this is the technical case. Now, if you look at the next case, which is the business case, why are we testing? From a business point of view, if you don't find bugs, your customer is going to find the bugs. That is the worst thing that can happen, right? Why? Post-release debugging is the most expensive form of development. So if the customer calls and say, look, I can't do this, so I can't do that. There's an issue here, there's a bug here. Then, my gosh, we are asking the customer to stop their work, which is very expensive for the customer. And they will never give us any other software in the future because we did not test properly, right? So buggy software hurts operations, sales, and reputation. Buggy software can be hazardous also to life and property. Last week we spoke about the X-ray machine, yeah, where it was overdosing the patients and they will die. So it's hazardous, okay? And then nobody is going to come to your hospital because you are killing people. And any hospital will never buy your equipment because that will also have serious issues. Okay, so here's the next case, the professional case, right? So we're looking at different cases. Why are we testing? So here, the test case design is a challenging and rewarding task. So if you are a professional QA person, designing a test case is actually adding to your professional life. So you can say, look, I've developed the test cases for this project, and the other project. And if your test cases are good, as in if it finds issues and problems and cases, that will give you confidence also yourself, right? And then systematic testing allows you to be more effective. So now testing, we don't do randomly. We learn the process. You realize it's a very systematic way of doing things, right? And when you are doing it properly in your organization, and if you're finding issues and helping the developers to fix their problems, you will earn your reputation in your company, right? You'll be well known as a great tester. Here's the last one, the economic case. Economically, like when it comes to money-wise, right? Defects get introduced in every phase of SDLC. That means our programmers are human. They keep on, introducing various bugs. So we can't stop that. It happens. More experience you have, less bugs you will introduce, but that doesn't mean you will never introduce bugs. Anything is possible. Next one, according to the Pressman, he says defect amplification model. What does that mean? What is amplification? Amplification means getting bigger. So if you look at the SDLC phase, when you introduce something in the requirement phase, and if you don't fix it there, and if it goes to the next one, which is the design phase, the bug also will amplify. The issue will amplify, right? That's the issue here. And it is amplifying the issue, and the cost is also getting amplified. If you can fix the bug for $100 in the requirement analysis phase, it might be $300, maybe $500 when you are fixing it in the design phase. This money is about salaries and time and everything else. So there's in fact something called a phase containment of errors. There's a principle called phase containment of error, right? That means if you can fix the error where it is happening, where it is started, then it is cheaper. That is the principle of phase containment. Yeah. So the point of introduction, if you can find out and fix it, you are very, very cheap. Yeah, showing this. If you look at the phases, now this is the SPLC phase, right? So number one is this one, requirement phase. Number two is design phase, then implementation phase, testing phase, and maintenance phase. So the amount is getting up, isn't it? So effect of introducing bugs and fixing here in the requirement is 1. It is double generally in the design. It is 3 times. No, not actually 3 times. So it's about, yeah, almost 20. So you can see the last phase, right? The maintenance is jumping all the way up to 60. So if you take it as a percentage, so this is about 10%. This is about close to 20. This is again about maybe 12 something. Here we are talking about 30 something, and then it's going all the way up when you try to fix it in the maintenance phase. Now to understand the containment, here's the ratio. Now this is also something we use in software testing. Phase containment effectiveness we call, right? With a very nice example. So during the design phase of a product, 10 faults were introduced. Right? In the design phase, there are 10 bugs introduced due to various reasons. Out of the 10, 7 were found and fixed, let's say. Right? 3 went to the next stage. So in that case, there are 7 errors, 3 defects went to the other side. So that's called 70%. 70% is the PCE, phase containment effectiveness, because out of the 10, we found only 7. Okay. So we can say our ratio is 70% here. Now, if you look at reasons for testing, okay, here's a reason. Testing for improve quality, right? That can be a reason. So as it says, as computers and software are used in critical applications, the outcomes of a bug can be severe. Now, software is everywhere nowadays, right? Your mouse, your remote control, your hard disk, not just laptops and phones, they are everywhere. So humans are writing the software. So these bugs can cause huge losses. And especially the bugs in critical systems can have all kinds of huge disasters. Right? Plane crashing to space shuttle system going north or south, even stock market crashing with lots of money being wasted and whatnot. So even they can kill people, you know. So you got to be very careful about software development and understand the role of software testing, that it's very, very important. Right? That is the objective here, understanding the importance of the SQA, software quality assurance. And one more reason, testing too, verification and validation. Testing can be served as metrics. So there can be numbers also, right? So we can, like we saw, like there were 10 bugs, 7 were found. Now these are numbers. Now these numbers are important for estimation later. So we look at reliability estimation and also work estimation. So next time when you are developing a program, you know, okay, for last time we had a 70% PCE. This time we need to reduce it down to 90% or increase it to 90%. How can we do that? Right. So because when you measure it, when you measure, you can manage. If you can't measure, you cannot manage. All right. So good testing can provide measures for all relevant quality factors. Right. So testing is very important because it can give higher quality product. And another one is reliability estimation. Now, this might be a legal requirement sometimes. Yeah. When you are developing a software application, there may be a legal requirement to get a third party involved, test your software and give some numbers on reliability. Say, for example, what is the maximum number of simultaneous connections your e-commerce site can have? Is it 1,000 or 1 million? When are you crashing? Is it 10,000 or 50,000? When are you crashing? And then based on an operational profile, an estimation of the relative frequency of use of various input to the program. So you give different kinds of input, different kinds of output, and then you try to get some statistics running here, right? So we understand where it is crashing or what is the maximum we can push it to, maximum levels of pushing. Yeah. So those are some of the things we can use testing for. Right. Now, I also have a bunch of test cases, actually software cases where I failed and brought in a lot of trouble. I think we discussed briefly some of them last week, but these are a recent one. Yeah, this is from India, the first one. 2012, May 31st, Indian Air Traffic Control at Delhi Airport launched their new software called the Auto Track 3. System completely failed. So Imagine radar system not functioning. So planes can't land, planes can't take off because the radar is not there. So if the radar is not working, plane might crash onto each other and killing hundreds of people. So luckily, nobody died, but they had serious issues. Imagine radar going blank for 10 minutes and then another 25 minutes on the July 28th, right? And then the radar scope didn't work on February 10th. So there's some serious trouble coming from the previous version 2. Then another few, I think Terak we spoke about. Toyota Prius 2010 version also had a braking problem. It was an embedded software issue. And due to that, the brake system doesn't work. Imagine you're running on the highway and the brake system doesn't work. You're going to crash the car and probably might die also, right? So we spoke about the Terak incident where it was overdosing people. Was also another serious issue we had. And then PlayStation, Sony PlayStation has a server version where you need to log into the system and then use your account rather to play the games. So there also, due to certain software bug, they lost lots of accounts, which meant $170 million to Sony. Right? So these are some of the cases where we had some severe problems. Now let me show you our LMS. I hope you went through the LMS lessons. There's a recording as well. Right. So this is our LMS page. So this I showed you last week. So use this for forum for discussions. Yeah. And I also given you some links to the books. I'll add another book today specifically on SQA. So these are general purpose document having SQA chapters, right? So each one has a chapter on software quality assurance and software testing because that is one of the most important aspect of software development as well. And these are the failure cases I have. So you can go here, read about it. And there is also a YouTube link explaining you what the issue was. So please go through that, have a look at it. Right. I'll get the week to update it. Any questions?